Hi, my name is Sofina binti Mamuar. My numerator is 2211511575, and today I will explain about question number 1, part A. Okay, the first question is Sn, the signal, equal to negative 2.7 exponent power of negative 0.4 plus j pi divided by c multiplied by n. So the n is defined as range of value 0 from 82, and j is imaginary unit. Square root of negative 1 is represent for complex number. Y0 we take from the formula for the question that was given. So this part of coding, we produce a figure. So the function of subplot is to create a grid. Subplot 311, meaning the 3 in the front is a row in the grid, and 1 in the middle is the number of column, and last one at the back is the position of the subplot. The stem plot is to set n at x-axis and y0 at y-axis, and we can name the graph with set title, and we name the title with the question itself. So this is a result of question 1, number 1 graph. So as we can see, we set the range from 0 to 80, and the title is question itself, and the x-axis is n and y-axis is y0. So this is graph for number 1A question. So this is the coding for Python. As you can see, the whole coding is quite similar with MATLAB coding, but the only difference is the Python has NumPy, Matplotlib, and J represented by 1J. So the NumPy is for numerical and Matplotlib is for plotting, and in the Python, J is represented by 1J. So the other coding below is still remain the same. So this is graph for Python. As you can see, the graph is similar to first graph in a MATLAB. So the Python graph and the MATLAB graph is similar. The second question is 0.8 pi n plus 0.3 pi multiplied by cos. So n in the coding is represent of range of value from 0 to 10 with increment 0.1. X will take from the question, and the subplot 312, meaning the figure will have 0, 1 column, and will focus on the middle subplot. So the stem is for set n at x-axis and s at y-axis. So x-axis coordinate we will label with n, and y-axis coordinate label with x, and the title is discrete signal. So this is signal for second question, signal figure for second question, and you can see the range is from 0 to 10 as we said in the coding, and the title is discrete signal, and the n is at x-axis and x is at y-axis. For the Python coding, we can see the coding is quite similar with MATLAB coding, but the difference is in the Python use NumPy for numerical operation and Matplotlib for plotting. The signal in the Python also similar with the MATLAB signal result. The third question is sine multiplied by 0.1 pi n plus 0.5 pi minus 3 cos multiplied by 0.8 pi n minus 0.2 pi plus cos multiplied by 1.3 pi n. So the n in this coding is to represent the range of value from 0 to 2 pi with increment 0.1. So the y2 is we copy from the question. And the subplot is 313, meaning the figure will have 3 row, 1 column, and we'll focus on the third subplot. So the stem we set n as x-axis and y2 at y-axis. So the title for the graph for the figure is the question itself. So the graph is from 0 to 2 pi as we said in the coding, and the title is question itself, and n is x-axis and y2 at y-axis. As we said, n as we label n as x-axis and we label y2 at y-axis. So same with the past question, the Python coding is closely similar with MATLAB coding. The only difference is NumPy and Matplotlib. So the NumPy represent as numerical operation and Matplotlib is represent as plotting. So this is graph for Python. As you can see, the Python graph is similar with MATLAB graph. Next question is 2 delta multiplied by n plus 3 minus delta multiplied by n minus 4. So the n is range of values from 0 to 2 pi with increment 0.1, and the new n is right from range -5 to pi with increment 0.2. So impulse 1 is create an impulse signal where the value is 1 when n is equal to -2 and 0. Impulse 2 will create another impulse signal where the value is 1 when n is equal to 4. So H is define the signal in the figure. So twice impulse 1 minus impulse 2, we will get 0. So the subplot is 312, meaning the figure will have 3 rows, 1 column, and will focus in the middle of the subplot. So stem is set n as x-axis and h as y-axis. So the title is discrete signal. So this is the signal as we define the h, and after minus the 2 implies and we get 0, and 2 implies start at 0, and the range is from -5 to 5, that the new n that we set in the coding, and the title is discrete signal. So that is Python coding. Again, as you can see, the whole coding is similar with MATLAB coding except for the NumPy and Matplotlib. In Python, we use NumPy as a numerical operation and Matplotlib for plotting. So this is signal for Python. As you can see, the Python signal is different compared with MATLAB signal, which is the all signal is lie on 0. So this is coding MATLAB for this question. N is range of value from 0 to 20 with increment 1, and y1 is step function that start at 1 for n bigger than 0 and become 0 for n bigger than 10. y2 is step function start at 1 for n bigger than 10 and become 0 for n bigger than 20. Y define combination of step function and exponential term. So the subplot is 3 to 5. So the figure will be have 3 row, 2 column, and will be focused on the fifth subplot. So for the stem, we will plot n at x-axis and y at y-axis. So this is the correct one plus the title. So this is a unit step graph range from 0 to 20 that we set in the coding, and n is at x-axis and yn is at y-axis. So same with other question, the Python coding. This Python coding is also similar to MATLAB coding. The only difference is NumPy and Matplotlib. The NumPy is for numerical operation and Matplotlib is for plotting. So this is graph for Python. As you can see, the Python graph and the MATLAB graph is similar.
Selamat sejahtera, my name is Siti Nur Faizah binti Hasmani. My number matric 221151574. Today I'm going to explain about part A, question 2A and B in the coding of MATLAB and the Python. Let's explain the question 2A MATLAB. The number first line. The line creates a vector and ranging from 0 to 12 with step of 1. Number 2, the lines define a vector x with a given value. Example 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. The match shift 10, this line, set the variable match shift to 10. N mean n's equal mean n's minus max shift. 1 max n plus max shift is here n is the update to include additional value from mean to max shift to max and max shift, effectively extending the range of n. So the 5 is the lines is 0 1 max shift x 0 1 max shift. 0 are added to and n of vector x to account for the cellular shift later. And then the y1 and Krivsky x5. The vector x is circularly shifted to the right by 5 position and the result is stored in y1. y2 Krivsky x minus 4. Why this type of the vector x is circularly shifted to the left by 4 position and the result is stored in y2. This is the vector y1 and y2 are multiplied by 2 and negative 3 respectively and then added element y to create a new vector y. Stem and y grid. The stem function is used to create a stem plot of the value in vector n and y. The grid function is called to display the grid line in the plot. The title. Question set the title of the plot to question 2A. For the example, the answer is given by this. Okay, this is the plot, the answer of the graph. In summary, this could generate a stem plot of a manipulated signal y based on cellular shift of the original shift x is a specific scaling factor. The cellular shift are created using the Krivsky function and the result plot is displayed with the title question 2A. So this is the question for the answer for 2A MATLAB. Okay, the question 2 for the B in the coding of the MATLAB. Let's break it down step by step. Okay, the first one is the question 2B. Okay, the n is the line creates a vector and ranging from 0 to 12 with a step of 1. Okay, 0, this is step, the range per step, range, and 12 is the last one. X is 1, 2, 3, 4, 5, 6, 7. This line defines a vector x with the given values. And the match shift 5, this line set the variable match shift to 5. Another line is the update the vector and to include additional value from mean and to to the makeshift to max n plus makeshift, extending the range of n. X0, 1 makeshift, X0, 1 makeshift. 0 are added to boost n of the vector x to account for the cellular shift later. Okay, the number 6, the vector x is cellularly shifted to the right by 2 positions and the result is stored in year y2. 7, code is this a flip x. The vector is a flip left to right using the flip LR and store in A. Makeshift 5. The variable makeshift is set to 5 again. Numbers 9. The line number 9. N min x minus makeshift 1 max plus makeshift. Update the vector n again. Line number 10. A 0 makeshift. 0 are added to both ends of a vector A to account for the cellular. For the cellular shift later. And line number 11, Y1 script shift A3, the vector A is cellularly shifted to the right by 3 positions and the result is stored in Y1. Now line number 12 is the Y3 xy2. The combination of vector x and y2 is calculated and stored in y3. Line number 13. This is y1 0 12 1 plus y3. A new vector y is created by concatenating y1 is a column vector of 0 to match dimension and adding it to y3. Line number 4 is from the create new figure window with number 2. And the subplot 211, create a subplot in the figure with 2 rows and 1 column and select the first subplot. Okay, 2, 1, 1. Line number 16 is the stem y, create a stem plot of the value in the y. And the line 17 is the x label n, y label ysn for the graph, x, y, n, and n, set label for the s as x. The title question 2, set the title of the subplot to question 2b. And in the summary, this code generates a stem plot of a signal y that is a combination of cellular shift and combination of the original signal x. The plot is displayed in a subplot with specific label and title. Okay, let's go for the question number 2A from the coding Python. The first one is from the line number 4. Number first is import the numpy library as np for numerical operation and the payplot module for matplot library from the plotting. And number 2 is the array. Define the sequence as n as the numpy array made from this. And the defined value of n is as a numpy array using numpy arrange. Okay, 0 until 13. Makeshift 10. Set the variable makeshift to 10. Number 5. Line for the 5 is the pad the sequence as n with a 0 on the boost and using np pad to account for the cellular shift. Line number 6, perform a cellular shift to the right by a 5 position and store the result in y1 using np roll in brackets. Line number 7 is the perform a cellular shift to the left by a 4 position and store the result in y2 using np roll. Calculate the sequence. This is the sequence that given from the questions. And calculate the sequence to the MATLAB, to the Python. Line number 9, update the value of n to match the extended range after the cellular shift. 10 is the create a stamp plot of the value in y, again the value in n using plot stamp to the plotting in the graph, and as level n set level for the y x axis and y axis and x axis. Set the title of the plot. Set the title. Display the grid on the plot and show the plot. This is the code for the show the plot. In summary, this Python code generates a stamp plot of a signal y based a cellular shift and the original x with specific scaling factor. The plot is displayed with a label, title, and grid. This is a grid and title and label from the x and y. Okay, this is the final answer from the graph. 2A Python. Okay, let's move to the question number 2B Python. Here the explanation of the provided code in point by point. The first one is the importing libraries. The code begin by importing the necessary libraries, numpy for the numerical operation and matplotlib library pyplot for plotting. Define the sequences as n. A sequence as n is defined using numpy representing a discrete signal with value 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1, and define the n value defined using numpy range function representing the discrete time in this from 0 to 12, and then number 4 is the padding the sequence with 0. The sequence Sn is paid with 0 on both sides with np pad to allow for the circular shift without losing information. 0 start from 0 and last for 0. Performing circular shift. 3 circular shifts are performed on the paid sequence. This y2 is obtained by shifting Sn to the right by 2 positions. Y1 obtained by flipping Sn and then shifting it to the right by 3 positions. Y3 is obtained by convolving the padded sequence with Y2. Adjusting lengths for addition. The length of Y1 and Y3 are adjusted from the addition by padding a shorter sequence with 0. And then number 7 is combining sequence. The sequence Y1 and Y3 are combined element-wise and the result is stored in Y. The result is Y. The 1, 1, 3 in combined. Plotting the final sequence Y is plotted using the code PLT stamp in bracket with label title grid for better visualization. From the plot y axis and the title. Plot interpretation, the plot represents the result of the expression x3, the given sequence and the circular shift. Visualization, the stamp plot visually displays the value of the combined sequence y over the discrete time in this. This code anciently demonstrated circular shift and manipulation of the discrete sequence in the context of the signal processing. Okay, that's all for the question number 2B for the coding Python. Thank you.
Assalamualaikum and hi, my name is Muhammad Taufik bin Muhammad and my metric number is 2111511311. So today I am going to demonstrate the question from part A, which is question 3. So in question 3, required us to show the even and odd component for this kind of signal. So as we can see, the Xn signal is a combination of two unit step signal. Slide. So the first slide shows that the UN signal. How do we get the UN signal? As we all know, UN is a unit step signal, and from the equation itself, we all know that it is in discrete time signal because it uses n instead of using t. If the signal is in t expressions, then it means that it is in continuous time signal. So let's go from the first line, n equal to negative 20, 1, and 20. This line means that the graph will start at negative 20 with step size of 1, and it will end at 20. So next, x1 equal to step fun and 0. So this is used to express the unit step signal. So the signal will start at n equal to 0. So it will goes until infinity. So next we use stem and x1 because it is in discrete time signal. So we use stem. But if it is continuous time signal, so we should use plot instead of using stem. Next is the title. Y label is on the y-axis, and x label is on the x-axis. So for the next slide, I will show you how we get the signal for UN minus 12. So this signal has a time shifting. So let's go from the first line. It's the same as the previous slide. So let's skip that and goes to x2. So x2 equal to step 1 and 12. So this line means that the signal will start, the amplitude one will start at 12, and it goes until infinity, as we can see from this graph below. So the amplitude start at 12 and it goes until infinity. So the subplot 322 means that the position for this figure is at position number 2. So we use stem as the same like before because it is a discrete time signal, and the title and the y label and x label. So for UN minus 12, the signal is like this. So in this slide, I will show you how we do the subtraction for UN and also for UN minus 12. So in this figure, the figure below shows that the result for after we subtract the signal from UN and also UN minus 12. So x3 shows that x1 is the UN and x2 is the UN minus 12. As we subtract both of the signal, we got the final signal like this. So after we finish subtract the signal, next step is we are going to flip the signal. So it is because to find the odd and even component, we need both xn and also the flip of xn. So in this slide, let's go to the second line, which is x4 equal to flip x3. It means that it will flip the signal x3 that we got before this. So it will flip that, and the title would be x negative n. So after we find the xn and also x negative n, so the next step we are going to do is find the even component. So to find even component, we are going to use this formula, which is x even equal to xn plus x negative n divided by 2. So the operation, we can write it in MATLAB using like the second line, x5 equal to 0.5 multiplied with x3 plus x4. So after we do the operation, we get the signal like this. So next, we are going to find the odd component. To find odd component, we are going to use this formula. XR equal to xn minus x negative n divided by 2. So this formula can be written in MATLAB code using like the second line. X6 equal to 0.5 multiplied with x3 minus x4. So after we did all the operations, the final signal will be like this. So in this slide, I will show you how the Python coding works. So the first thing that we need to do is to include the NumPy and the Matplotlib library into the Python. So NumPy is often used for numerical operations, while Matplotlib is commonly used for creating visualizations and plots. So basically, the Python coding is the same as the MATLAB coding. It's just that we need to include the PLT in front of the subplot, stem, title, y label, and x label. So let's go to the first subplot. So the first subplot is the unit step. Shows the unit step function un, where the amplitude 1 it will start from n equal to 0 until infinity, while the amplitude will become 0 if n less than 0. So for the second subplot shows the un minus 12, which is a shifted version of un by 12 units to the right. The third subplot shows the difference between un and un minus 12, resulting in a signal that is 1 for n for 0 until 12 and 0 for otherwise. The next subplot shows the negation of the signal from the third subplot, effectively flipping it. So in this slide shows the coding that we write to obtain the even component and the odd component. So the even component is obtained by adding the original signal and the flip signal and then divided by 2. The same goes to the odd component. The odd component we need to subtract the original signal and the flip signal, and then we divide it by 2. So the last two code lines, which is the plot type layout and also the plot shows, we need to write to ensure that the subplots are neatly arranged and to display the entire plot. So this is the result that we obtain by using the Python coding. It is the same as the MATLAB coding. We got the odd component and also the even component.
Hi, in this video I will show you how do we get the odd and even component. So let's take this example for xn. We got 0, 0, 1, 1, 1 and the origin is at 1, so the signal would look like this. So we need to find the flip of xn, so we flip at 0, so the signal will be 1, 1, 1, 0, 0 and the signal will look like this. So next we go to the formula. To find the even component, we use this formula xn plus x negative n divided by 2. So let's take example for n equal to 0. So we look at n equal to 0. The amplitude is 1 for xn and the x negative n also 1. So we put into the formula, so we get 1 plus 1 divided by 2 and we got 1. For n equal to 1, let's look at the signal. For xn, the amplitude is 1 and for x negative n, the amplitude is 0. So when we put into the formula, we got 1 plus 0 divided by 2 and we got 0.5. The same goes to n negative 1. So we look at the signal. For negative 1, for xn, the amplitude is 0 and for x negative n, the amplitude is 1. So we put into the formula, so we got 0 plus 1 divided by 2, we got 0.5. So the final signal that we get for x even is 0.5, 0.5, 1, which is the origin, 0.5 and 0.5. So the final signal will look like this for even component. Next, we go to odd component. To find odd component, we use this formula. X odd equal to xn minus x negative n divided by 2. For n equal to 0, let's look at the signal. So for xn, 0, the amplitude is 1 and the same goes to x negative n. So we put into the formula, so 1 minus 1 divided by 2, we got 0 for n equal to 1. For xn, when n equal to 1, the amplitude is 1, and x negative n is the amplitude is 0. So we put into the formula, we got 1 minus 0 divided by 2, we got 0.5. The same goes to n negative 1. So the amplitude for xn when n negative 1 is 0, and for x negative n, the amplitude is 1. So we put into the formula 0 minus 1 divided by 2, we got 0.5. So for the odd component, we got the final result like this: negative 0.5, negative 0.5, 0, which is the origin, 0.5, 0.5. So the final result will look like this.
Determine the response of the LTI system whose input is n equal to 2, 13, 40, negative 1, negative 4, negative 2, origin at 0, and impulse response n equal to 2, 3, 0, negative 5 to 1, origin at 3. So this coding will produce three figures. The first figure is input signal, the second is impulse response, and the third is Q4 linear convolution. So we look at first coding, then the nx, then nx is the range for discrete variable, n for sequence x, and x is defined the value of sequence x corresponding to an x. And nh is defined the range for discrete variable n for sequence h. H is the value of sequence h corresponding to nh. So we move to the figure coding above. So for the first figure, which is input signal, the subplot is 311. So this figure must have 3 rows with 1 column, and will be focused on the first subplot. So the stem plot, we plot an x as x-axis and x as y-axis on the figure. So the x-axis we label as n, and y-axis we label as xn, and the title we label as input signal. So we move for the second figure. As you can see, the second and the first is similar step. So the subplot is 312. So the figure must have 0 with one column, and will be focused with the middle subplot. So the stem plot, we set nh at x-axis and h at y-axis. So we label x coordinate with n and y coordinate with hn. So the title we set as impulse response. So this is second figure. And for this coding, it is for this coding to perform linear convolution of sequence x and h and store the result in y. So the subplot is 313. So the figure must have 3 rows with 1 column and will be focused on the third subplot. So we will relabel x coordinate as n and y coordinate as yn. So the title is Q4 linear convolution. So this is Python coding for question, similar to MATLAB coding. The difference is the Python coding have NumPy and Matplotlib. So the NumPy is for numerical operation and Matplotlib is for plotting. So this is Python signal. As you can see, the Python signal and the MATLAB signal is closely similar.
Hi, my name is Sabrina Firdaus and I'll be presenting question 5 in part A. Now this is the question: compute the cross correlation between xn, yn, and plus a random noise. This is the coding, so for question 5. And here n negative 3, 1, 3, this line indicates that it creates a vector of n containing values from negative 3 to 3 with a step size of 1. and this x line, it creates a vector of x with these specified values. This is the figure that will show our plot, and max shift equals to 2 is it means that the line sets the variable max shift to 2, and this equation right here, n, is an updates the vector of n to extend the range by subtracting max shift from the minimum value and adding max shift to the maximum value. Now the x here, this line pads the vector x with zeros on both sides, effectively extending it to accommodate circular shifting. Now the y equals to circ shift here, it performs a circular shift on a transposed vector x, where it will shift the value circularly by 2 positions and adds random noise generated by rand, here the rand. Now y1 lags here, it means that it calculates the cross correlation between vector x and vector y and returns the result in y1 corresponding lags in the lags, and this stem, it creates a stem plot for the cross correlation values against lags. And the last line, it actually just vector to its original values because it's actually redundant because we already put it in the first. And so in summary, this MATLAB code generates a signal x, performing circular shifting on it, adds random noise, computes the cross correlation with the original signal, and plots the result. And so the variable max shift controls the circular shifting and padding. The resulting plot shows the correlation between the original and shifted signal. This is the result that we plotted. Now for the Python coding, this is the Python coding for the question 5, where this import and this to import is actually just an alias for NumPy library and Matplotlib. N and P arranged, this is the values from -3 to 3 with a step size of 1. And the second one, it actually a NumPy array x with these specified values, and variable max shift equals to 2 is actually just the same with just now. This one create extended n and x with zeros padding, which means that it extends the vector n and x by adding zeros on both sides. N is updated to have a range from the minimum value of the original n minus max shift to the maximum value of the original n plus max shift. Now 0 is added to the beginning and the end of the x. This part where it generates random noise, it actually creates a new array y by circularly shifting x by 2 positions and adding random noise generated by np.random.rand, as we can see here. In the compute correlation y1, it computes cross correlation of x and y using np and with the mode set to full. The lags are generated using np.arrange here to cover the possible lag values. At the plotting the result, plots the stem plot of the cross correlation values against lags using Matplotlib, where we already declared at the beginning of the coding, and we set the label x axis, y axis, and also the title. And plt.show is just display the plot, where this is the plot, and the stem plot shows that the cross correlation between the original and shifted signals. Thank you so much.
Hi, Assalamualaikum. My name is Nafifah binti Rozi, and my metric number is 22115154. Today I will be going to explain the part A of question 6A and 6B. First, I will be going to explain the MATLAB coding. For this question 6A and B, it requires us to determine the circular convolution of the following pairs of the sequence. For A, it is a sequence of xn and vn. So in the coding, we will rewrite the sequence of xn and vn. And then we will use the method of C, CO, and V in order to get the circular convolution of V and X. Here you can see we use Y equal to C, CO, and V of X and X. And the signal will be plot into the subplot of 2, 1, 1. And since the signal is in discrete signal, we will use temp syntax, and here we use fill, which means the signal will be filled with colors. And the title of the signal is circular convolution using C, CO, and V. And then the second method is we will using the DFT and IDFT method. Here, for this method, we have to add 0 to both of the sequence in order to get both of the sequence into the same length. So here we represent the sequence in XPath, which mean the X will be padded with 0, and V pad means this V sequence is padded with 0 too. And the length of both of the signal will be 9 here, as we stated here. And then we will use the CCIRC, means with inverse transform of Fourier transform of X pad convolved with the Fourier transform of V pad. And here from this equation we will get the circular convolution of both X and V too. And from this code we will plot it in 2, 1, 2. Same as before, it is in the stem syntax, which means it will be in a discrete signal, and it also is filled, which means the color is filled. And the title of this signal is circular convolution using CCIRC, and this is the signal. For question 6b, we are also required to determine the circular convolution of the following pair of xn and hn. It is stated that n is greater than 0 and lesser than 4. Therefore, in the coding, we will state that n is equal to 0 until 4 with the increment of 1. And then we will rewrite the coding, the equation of x and h. And then we will use the same method as in the 6a, which is CCONV of x and h with the length of 5. And then we will subplot it into 2, 1, 1. And then the second method is the IDFT and FFT method. We will add the 0 padding to x equation and h equation to the length of 5. Why we use the length of 5 instead of 9 like in the question 6a? It is because that there has been stated that n is equal to 0 to 4, which means if we calculate the 0 to 4, it will be 5 in the length of the x-axis here. Okay, and then we will use the CCIRC equal to IFFT of FFT x pad convolved with FFT h pad, and then we will get this output signal here. Next, I will be explaining the Python coding of question 6a and 6b. For the Python coding of this question 6a, first thing first, we have to import the library first. Here we import the numpy as np and import matplotlib pyplot as plt. And we will define the xn and vn equation of np array of the xn equation and np array of vn equation. And here we will use only one method here, which is the IDFT and FFT method. First thing first, we have to add the 0 padding to the x equation and v equation. As you can see here, there is a mode constant, which means the 0 padding mode is in constant and the value of the constant is 0. And then we will do the Fourier transform, fast Fourier transform of the x pad, and then fast Fourier transform of the v pad. And then the convolution result will be the inverse transform of the convolution of fast Fourier transform of x and fast Fourier transform of v. And then the coding here is shown for the plotting of the graph. Here the figure size is 10 inches width and 5 inches height, and it will be subplot into 1, 1, 1, and it will arrange into the n convolve. And the title is the circular convolution result real type. The x-axis is labeled as n, the y-axis is labeled as amplitude, and here is the coding for the signal to be shown. This is the result of the Python coding of 6a. As you can see, this result is the same as the MATLAB coding of the question 6a that I have shown. For Python coding of question 6b, first thing first, we have to import the library first, numpy as np and matplotlib pyplot as plt, and then define the sequence of xn and hn here. And then the n equal to np range is 0, 5, and 1, which means the signal will start with 0, and the length of the signal is 5, and the increment of the signal is 1. And then in this Python coding, we will only use one method only, which is IDFT and FFT method. First, to do the IDFT and FFT method, we have to do the 0 padding of X equation and H equation. As you can see that the length of the signal is only 5, therefore the padding of the signal is also 5 only here. And then to do the to get the result of the circular convolution of this equation, first we have to do the Fourier transform of the X pad and Fourier transform of the H pad, and then we will do the inverse transform of convolution of Fourier transform of X and Fourier transform of H. And this is the coding for the plotting. The figure size is also 10 inches in width and 5 inches in height. It will be separate into 111, and the title of the signal will be circular convolution result. The x-axis is n and the y-axis is amplitude. And this will be the result of the question 6b of the Python coding. That's all from me. Thank you.